All right, let's get started. Ooh, I had a bit of a battle in the kitchen. Um, but I'm here now. So, hello there. Hello. Um, I'm gonna start by changing my soldering tip because we're gonna be dealing with some SMD components. So I'm gonna switch to a sharper tip. Which one? Which one is sharper? This one. I haven't used this one yet. I've only been using this soldering tip ever since I got this soldering iron, but I don't think that's gonna be accurate enough to handle individual pins of an SOT chip. So let me just quickly go through what I have here and maybe show it off with a little test run. So I have a couple of drivers here that I harvested from a JBL flip. I got a Bluetooth module with it's a Bluetooth receiver. It's a little microcontroller, and then this here is a Class D amplifier. This thing claims to be able to be powered, well, nominally by 5 volts, but they claim that it should also run at a more variable range of voltages, from something like 3 volts up to 7 something, not sure. So in theory, it should be fine running off of a lithium battery pack, which has a nominal voltage of 3.7. It goes, well, I got some Samsung 35E cells in parallel. Their voltage range is 2.8 volts up to 4.2. 4.2 is a nominal maximum voltage for pretty much all lithium cells. But I noticed that the microcontroller is not very stable below 3.5 volts. So that's something I'm gonna have to address. But then I have a TP4056 lithium charger module. There's a TP4056 which provides a constant current and constant voltage, and cuts off once the voltage of a lithium of the charged cell reaches 4.2 volts. Then there's a DW01 protection circuit which protects from over and under voltage. So it controls the two MOSFETs in the third package here. And those cut off the power to the cell if the voltage either goes too high or drops too low. And then, so this here is the connector to the battery pack. And this is my output voltage that I can connect directly to the Bluetooth module. And when I do so, actually I haven't connected the, okay, let's disconnect this again. Let me connect the speakers first. This is right, this is left. And now, if I connect this, connect the power, it turns on. get a little potentiometer. And I can, in theory, connect my phone to this. For some reason, my phone is not... Okay, it connected to the Wi-Fi now. Okay.
The Bluetooth device is connected successfully.
So my phone has connected and the blue LED has stopped flashing. It's continuously lit. And now I can play music over it, and it plays. The quality of the music is kind of shit because the drivers need some sort of box to have decent sound. But the basics work. There's a little potentiometer, a couple of buttons to adjust, yeah, to skip to the next song or previous. I'm gonna disconnect the power here. Doesn't have a button to toggle off and on. So I'm just gonna solve that using a mechanical switch. The board also came, like this seems to be some prototype version. It differs in layout slightly from what was pictured in the listing when I ordered this. Most importantly, there were 4 holes here marked 5 volt, ground, DN, and DP, which oddly enough matches the pinout of a USB 2 port. So I soldered a header to it with some wires. And indeed, it is a USB. So this microcontroller has a USB interface, which can be used to program it. But it is a little bit, it requires a custom trigger board to enter USB mass storage mode. Some people have reverse engineered it. So I'm gonna try to experiment with that at some point, because that would make it possible for me to change the audio clips that it plays when it turns on and when you connect or disconnect the device. Because yeah, they have pretty horrible accent, the ones that are pre-flushed in the firmware. So we'll see if I manage to do something about that, but that's for another day. What I want to focus on today is I have this charging board. In fact, let me get a multimeter and some hook leads. The charging module works beautifully with one caveat. It assumes that when you connect this to a USB port, there's going to be 5 volts automatically. And that's not always the case with more modern power delivery capable chargers. But let me just quickly measure the voltage across the battery pack. Okay, so it's 4.15, so it's almost fully charged. Not entirely 100%, but close. And now if I bring a USB cable. This is a regular USB 2.0 with a little, it is, yeah, micro USB to USB-C adapter. If I connect it here, I can see that, yeah, it's started to charge. That's a red LED indicates it's drawing about 0.5 amp. The voltage on this has gone up, so now it's maintaining a constant voltage and just monitoring how much the battery is drawing the current until it's fully charged. It's not going to go any higher than this voltage. So this works decently enough. However, that's a regular USB 2 charger. If I take a USB power delivery charger and connect it here, nothing happens. And this is a bit annoying because these power delivery smart chargers require the device to negotiate a voltage and power level, which this does not do because it doesn't have any such circuitry. So what I have for that purpose is this power delivery trigger board. There's another tiny module that I ordered from AliExpress, and it is configurable. If we can, is this going to focus? I might not be able to focus. Anyway, it has 4 positions for a 0 ohm link marked with 9 volts, 12 volts, 15 volts, and 20 volts. And you can solder this 0 ohm link to one of those positions, and depending on which one is connected, this chip will request the matching voltage from a power delivery source. I've done a little bit of reverse engineering on this chip. Even though they scrubbed off all the markings, it's a fairly standard affair, which is common in all kinds of cheap Chinese USB power delivery capable devices. And it is the CH224K, I think. Let me switch to this scene, and I have the datasheet. Yeah, it's the CH224K. So this is an interesting little chip. It's a power delivery, and it has support for power delivery and other fast charging protocols. So it also supports quick charge and a few others. And it operates in multiple different modes. So this particular board runs the chip in this configuration, resistance configuration mode. There are 4 voltage levels, which match what the trigger board recognizes, depending on a configuration resistor. So this is the schematic of it. There's this RSet resistor, which is connected between pin 9 of the chip and ground. Depending on the resistance of that, if the pin is floating, it requests 20 volts, which is why the 20 volt position here the 20 volt position, if you look closely, next to each of those positions, there's a resistor. except for the 20 volt. There's just an empty position for a resistor, but it's intentionally left empty. And then there's the 3 values, and the resistors, the markings on these resistors also match the datasheet. So this is one of the ways to recognize that, yeah, this is indeed a CH224K. Now, this chip is also able to operate in a different configuration mode, which is described in the next section, and that is the low configuration mode, which uses pins CFG1, which is also used in the resistance mode, but also CFG2 and CFG3. And in this mode, it's also able to request 5 volts. So I want to try modding this board to request 5 volts instead of one of these 4 voltages. So it should be fairly straightforward. I would simply, let's get this out of the way for now. I would need to get rid of this link because we don't need the resistance mode. I don't really care about these 3 potential configuration resistors because they're just going to be left floating. Let me switch to. So yeah, I would get rid of this link entirely. I'm going to verify that just to double check. These pads, I mean, so this side should be ground, and this side, these pads should be connected to pin 9. So let me just double check that that is indeed the case. I'm gonna switch my multimeter to continuity mode. And this here is ground, right? Yes, it is. And indeed, these pads are all ground. And then these should be, yes, that's pin 9 of the chip. Oh, this is interesting. Oh yeah, okay, never mind, it was just either some flux or corrosion. So this empty position is also directly connected to pin 9, which means I'm going to need to run a jumper between pin 9, and the chip also has pin, where are we? VDD. So that's pin 1. And that pin, according to the datasheet, let's see. Let me switch to another view mode. So, CH224K pin description. So pin 1 is VDD, this operating power input, and it's connected, yeah, via resistor to V-bus, and then has a capacitor to ground. Now let's quickly double check that pin 9, I've seen somewhere else in the datasheet that pin 9 is supposed to be held at a voltage of 3.6 volts, I think, or 3.3 maybe, not sure. Let's find out. But yeah, there's an example here. how to connect it to a Type-C female port, which is exactly here. But this is in the 3-pin configuration mode. And here in this example, they just show that CFG3, which they want to pull high, is just directly connected to VDD, which is pin 1. The absolute maximum ratings for VCC. Wait. Oh, okay. So operating supply voltage, 3.6 volts maximum. Voltage on CC1, 2, and CFG1, maximum 8 volts. Okay. This is kind of weird because CFG, there's no CFG without a number. I don't know. It's kind of weird. There are some inconsistencies in the datasheet. Oh yeah, so the typical VDD is 3.3 volts, I guess. So let's see if we get 3.3 volts on pin 1 relative to ground. And I don't want to short anything out. We have 1.5 volts. Interesting. Not how it's supposed to behave. Let me see that everything actually works the way it's supposed to. I connect it. Okay, it's configured to request 12 volts, but it's getting 9. I think this charger does not support 12 volts, so it chooses the closest lower configuration that it supports, which is 9 volts. Yeah, so we do have 9 volts here. But pin 1 is 1.5. Oh wait, no. No, never mind. No, this is pin 1. That was pin 2. Yeah, it's 3.3 volts. I was measuring the wrong pin. I got a little bit bamboozled by the schematic in the data sheet, because that also shows pin 0, which is at the bottom. Okay, so that works. So I got 3.3 volts. So I should be able to just actually directly connect the pin CFG1 to pin 1. In fact, okay, let's see if there's maybe a better spot that I can run a jumper. There should be a 1 kilo ohm resistor between V bus, which is exposed here, and yeah, so I guess that's this resistor here at the top. because it seems to be in series with the capacitor. So let's switch to continuity mode. And if I'm correct, then these two pads should be connected. Maybe I'm not correct. Oh, they are. Okay. So, and they should also be connected to pin 1. Indeed. So, I could run a jumper from pin 1 or either of these two pads. They're all common. And then run it to this here pad. And that, well, first I need to get rid of the 0 ohm link. So let's do that. Seems that my soldering iron temperature is not quite enough, because the solder does not want to stay. Come on. There we go. We got the link removed. I just try to clean up a little bit some of the excess solder, which we don't need. Okay, what's going on here? I think I might need to put a drop of flux in there, because the solder is not cooperating. That's a perfectly reasonable amount of flux. I really did not just drown the whole thing in it. Okay, that's better. It's looking fairly clean there. Just touch up some of the pads. Cool. Let me wipe off some of the excess flux with some isopropyl alcohol. So right now it's configured to 20 volt floating mode. I think this chip might be able to reconfigure itself at runtime So it doesn't necessarily maintain the voltage that it was started up with. So let's give it a try. I'm gonna grab some jumper wires. Yeah, so we can see that it requested 20 volts. So that's working as expected. Let me just pull a small jumper wire out of here. And now, if I connect the CFG1 to pin 1, I think I'm getting a good connection there. Okay. That's not working. Okay, never mind. So I guess I'm just gonna try to solder a piece of wire to both of those pads. And then see what happens when I connect those. This is enameled wire, so I'm gonna need to just burn off a little bit of the enamel. Get a little bit of solder here. And this is generally easier with a larger solder tip. But I think we got, yeah, we got a decent bit of exposed wire there. So let me try to get that hooked up to this pad here. Wow, okay, it seems that the tip was not correctly tinned out of the box. That's not great. Yeah, the tip is not taking solder. Ay, ay, ay. Trying to expose it to some flux. I might need to get some of those soldering tip rejuvenation pastes. Didn't think I would need that for the tips fresh out of the box. Oh well. Let me clean this up a little bit. Get a drop of flux there. Some first solder on that pad. That should make it easier to get that wire in place. That's beautiful. Okay, we gotta... Oh no. Oh fuck, I ripped the pad. That's not great. Well, there goes that plan. By the way, there's okay, you know, one step at a time. One step at a time. Might in the end be better to... Hang on. Actually, could just yeah, whatever. So I linked that to the other pad there. Or gets hot. Let's just check continuity between this wire and pin CFG1. Oh. CFG1 is supposed to be pin 9, yes. Well, this is awkward. Did I break something? Oh no, okay, we do have continuity. Hello? This is awkward. I didn't have continuity there for a bit. Hmm. Something's weird. We should still be getting 20 volts. Yeah, we do still get 20 volts. Why is the continuity not getting picked up? Maybe just need to clean up the pads. Maybe I just drowned it in too much flux. Okay, there's quite a bit of dirt there. Let's try again. Still nothing. Okay, I don't understand. Wait, did I rip a via? Is there a via under? Oh no. Okay, I think I see what happened. Okay. Yeah. Ripping that trace was not a good idea. Well then, plan B. I'm gonna need to connect the jumper directly to pin 9. I'm pretty sure that there was a trace running, like there's a trace connecting all 4 of these pads, and then from here I'm pretty sure it just dips underneath the chip and to pin 9. And since I ripped this pad here, I ripped it from the trace that's going under the chip. That's a little bit of an oopsie. So now I gotta solder this jumper wire directly to that pin of the IC, which is what I assumed I would have to do from the get-go anyway. Let's pick up a little bit of solder. Oh. I can barely see what's going on there. Maybe I should... I don't have a microscope. Get a magnifying glass, maybe? Hmm. Not getting a clean solder joint. Maybe I can try to get more solder on the wire itself. Okay, I think I got it. Let's take a closer look. Yeah, that's it. That is it. No. Okay, that wasn't a solid enough joint. Let's get a drop of flux here. Just to wipe off the flux. Okay, that's looking a little bit better. And now I need to bend the wire. And to get it connected to pin 1. Okay, that seems to be in a pretty good position. Let's get a drop of flux there. That was fairly clinical. Cool. So we got a link between pin CFG1 and VDD, which means we have pulled up CFG1, and now the board should request 5 volts. And there we go. The meter is showing 5 volts. So this trigger board is successfully requesting 5 volts from a smart charger. So that's the mod successful. Let me just quickly rinse off some of the excess flux. I'm just gonna directly squirt some isopropyl alcohol just to rinse it off. Wipe off any leftover excess. So that's this mod done. Next, there's more work that I would like to do on this tiny board. So let me just wipe my surface here. And also clean the... Might actually use the paper towel for this. So there was more that I wanted to do. Namely, if you look at this TP4056 board, you will notice that the USB connector extends past the edge of the board, which is good because I would like to mount it next to a... Just fold this down. Oh. Okay, maybe I should not do that. No, probably not. And I feel like I might have snapped this solder joint. Okay, now we have a more solid joint there. Good. I would like to mount the connector by a panel. And the thing is, that's not really possible with this board because for some reason they chose to place the connector entirely within the bounds of the PCB. However, well, so there is one component here that extends further than the USB port, and that's a little indicator LED. The problem is, the indicator LED is their own addition. It's not, doesn't have anything to do with the CH224. So it's just a separate circuit, and I have done a little bit of reverse engineering, and it seems that it's just the cathode of the LED is connected directly to ground, directly to the negative pin of the USB port, or to the jacket. Then there's a trace from the anode on the bottom layer going over here, and there's a Zener diode here. Thing is, right now with a 5-volt configuration, the LED doesn't even light up, so it's completely pointless there. So I'm thinking I'll just get rid of it. But I wanted to also check some voltages here out of curiosity. I didn't fully reverse engineer how they connected the LED. But yeah, so okay, the voltage of across the LED is 0. That would explain why it doesn't light up at all. I assumed that they just connected it. Oh wait, no, I had the lead in the wrong spot. So let's do that again. So the voltage across the LED is 1.3 volts. That's okay. Still not enough for it to light up. On the other side of the Zener, we got almost V-bus. No, wait. No, yeah, it's slightly less than V-bus. It seems that it's just in series. Resistor, a Zener, and the LED. It's an odd configuration. Let me just try to figure out some continuity here. So LED to Zener, yes. Zener to resistor, and resistor to V-bus. So it's literally just 3 components in series. Okay. Can I get the LED to light up if I probe it in diode / continuity mode? Yes, I can. So by that token, none of those components are in any way required for the operation of the trigger board. So I can just get rid of the, this here zener, this resistor, and this LED, especially because in 5-volt mode, they just don't do anything. So let's get rid of them. And then I'm thinking, because that is the only circuitry that extends past this point, which is where the USB connector is hooked up. Hey, Sanzone, welcome in. Science is up. No, not science, engineering. So I'm thinking I will just take a Dremel and cut off like 2 millimeters of this PCB so that the USB connector actually extends past its edge, and then I can mount it to a panel, and that should work. Wish me good luck. But yeah, first let's get rid of the LED indicator circuit. How are you doing, Sanzone? Long time no see. I hope life has been treating you well. Now, this can potentially sink a lot of heat because it's right next to the connector housing, which is unfortunate, but we'll give it our best. I don't have the proper tools to desolder SMD components. Ups and downs, more downs and ups. Aww. Sorry to hear, but good to see that you're still alive and kicking. Okay, you swap the LED off by heating both pads at the same time. Let's clean this up a little bit. Well, it looks like my tip is slowly recovering, so that's good. There's some excess solder here. I'm gonna try to wick it off. There. Huh, who would have thought that it would be hot? Cool, yeah. That's reasonably clean. So cutting out an actual board? You mean this? It is, well, it's about 1.5 millimeter thick. Has a color of 1. Well, I'm not sure what you're referring to, but yeah, it is a cutting mat. Like it says here. It's some weird plastic though. In theory, I don't need to worry about the Zener diode at all, because it's just going to be, you know, that bit of the circuit, so it doesn't really matter if it's there or not. But honestly, I kind of would prefer not to have it there. Just would have been funny if it was drawn like a circuit board. Oh, you mean a circuit board? No, no, no. That's a... Okay, so there's a 47K resistor in series with a Zener and LED. I guess they like that's a fairly high value resistor, but since this indicator circuit is supposed to work with voltages up to 20 volts, they designed it with that in mind. Okay, so we got the resistor off and it pinged off somewhere. It's probably never to be found. Hope it doesn't short out anything important. What did the USB used to be? What's the lore? Oh, you mean this little board that I'm modifying here? It's a USB power delivery trigger board. So, because what I'm working on here, I have a charge control board with TP4056 for lithium pack. And it comes with its own USB connector. The problem is if I connect this thing to a smart USB power delivery charger, it doesn't do anything. Because this doesn't have the circuitry to trigger power delivery. So I took one of these cheap AliExpress USB power delivery trigger boards, but this one comes with pre-configured positions for 9 volts, 12, 15, and 20 volts, but I wanted it to trigger 5 volts. So I had to solder a jumper wire here to reconfigure the chip. And now it does request 5 volts from the same smart charger. Wait, it's did I break something? Doesn't seem to be working anymore. Uh-oh. Well, it's not working anymore. Why is it not working anymore? It worked before. Hehe. Isn't that unfortunate? Charger is cursed. I mean, yeah, but it is the future of USB charging circuitry. Oh, I found the resistor. Let me get a new cotton swab. Whatever you pronounce it. Was this serving any other purpose? Okay, yeah. So the marking says 473, which should be 47K. Your door's lock broke today. Oh no! Rest in peace. Yeah, I've been there a few years ago, and holy shit, was that a pain in the ass. Let me just try to measure the resistance across this. Yeah, okay, so it is 47K. I need a better multimeter. But yeah, the multimeter was showing 47K. I guess his skill was a skill and the guy was really cool. So what did the locksmith have to do? Because when I got, well, I didn't get locked out, I got locked in, so I wasn't able to leave my apartment. And when I called the locksmith, he had to spend several hours cutting through my apartment door. That was fun. So let's quickly check some continuity here. Is this pad, so this pad should be connected only to VBus. Yes. So that's directly connected to VBus. Last year I had a broken lock again. Oh. So it's not even the first time. Rest in peace, Sunzone. Let me clean up this pad. When I get to gauges, he damaged enough for me to be... His drill got stuck inside the... Holy fuck! Somebody tried to break in with a drill while I was... Oh, yikes. Yeah. That's so stupid. Like, modern locks are not susceptible to that because they have drill protection. Why would somebody try that? It's not the 70s anymore. Of course, trying to drill a lock out is going to break your drill bit. I do want to continue removing these. Okay, so that's the Zener removed. Now, let's clean it up and figure out if it was connected to anything else. It shouldn't have been. So let's see. Okay, so continuity. There's not that many pads on this board. So these pads, are they connected to anything else? Not there. Not there. Not there. They really shouldn't be connected to anything at all. Not there. These are dead now because I broke them. Not there. Not there. Not there. There or there. So these pads are Nothing. This is VBus. This pad should only be connected to this. But this resistor is weird. I don't know what its purpose is. Am I looking through a magnifying glass? No. What is this resistor? It's 10K. There is no 10K resistor in the datasheet. But it seems to be connected to pin 8. So pin 8 should be VBus. Let's see, is pin 8 VBus? Wait. So this resistor is between VBus and pin 8. Why did they put a 10K resistor between pin 8 and VBus? Because let's check this out. So we're running in this configuration. Wait, okay, so maybe... I see. Okay, so if the chip is operating in resistance configuration mode, then VBus, there's a 10K resistor between VBus and pin 8. What's the description of pin 8? Voltage detection input is required to be connected in series with a resistor to external VBus. Okay, so in this configuration, it is connected through a 10K resistor. Oh, but it is okay. So it is in this case as well. Okay, never mind then. So it is. That is correct. That is correct. Never mind. So that was just me overlooking this. Okay, never mind. So that is correct. But now, why doesn't it work? Oh, it does work. Whoops. Yeah, so it does work. It does, wait. It requested 5 volts, but then shut off immediately. Why did it shut off? Why is it not keeping the voltage? It is working now. Something is fucky here. When I wobble it, it loses connection. But not in this direction. Not with this orientation. Interesting. Did I break something while desoldering the LED? Or maybe some of the flux got inside the connector. It was causing an unreliable connection inside. It seems to be working better now. Okay, I think we're good. I think we're fine. Okay. Panic averted. So we got the desired voltage. We got rid of the completely unnecessary power indicator circuitry, which doesn't work at this voltage level anyway. So now what I want to do is try to slice off some of the excess PCB. Just bend the wire out of the way. What I want to do is indicate with a ruler. How do I go about this? Just where I want to cut. I wonder why there, because, okay, so there are two vias here right at the edge on the ground plane. I suppose there is also ground plane on this side of the PCB. Yeah, it shouldn't really matter. Okay. Let me get a knife and try to indicate where I want to cut. There we go. And now let's get a Dremel-like tool. And cut it off. Gotta reach my toolbox here. I need better storage space. So I got my Dremel attachments. Now, which attachment would be suitable for this? I guess a cutting disc might be good. So either this, or I could use one of these. These are fairly thin, so let's use this fine cutoff wheel 409. I'm gonna need to get it attached. Which guy fixed Android multimedia system for a car? It's quite interesting. What was wrong with it? Come on. There we have that. Attached. Now. It's just therapeutic to watch. Yeah, I really like watching electronics teardown and reverse engineering and repair videos. I tend to I have learned a lot from content like that over the years. I'm trying to put some of it to use now. Did I cross-thread this? Hope not. Okay. We're good. Let's tighten the screw. Okay. Now. There's something too complex. You replace the chip and the capacitors. Didn't have the exact same chip, but it still worked. Mm-hmm. Yeah, that's nice though. Also knowing what you can replace it with. I'm just gonna quickly cover my drinks with coasters because there's probably gonna be a fair amount of dust here from the grinding disc. Whoops. Okay, this should cut like butter. Should probably put on a mask. Yeah, that's probably a smart idea. To not inhale all the dust. Watch my fingers too. Yeah. No worries. I'm good. I'm good. We're fine. I'm careful. The problem was the audio wouldn't work. It would just be noise, or actually, not sure. But also, Hyson, I have noticed you have been lurking from the beginning. All right, I have masked up. No idea how much it affected the voice of my mic. Also, I'm running the Dremel on the lowest speed. And I see that I'm already reaching the copper trace on the other side of the PCB, so we're getting through, or the copper layer. Yeah, we are not quite through the copper, but getting there. I don't want to cut into the housing of the connector though. At least not too much. The slight nick wouldn't be too much of an issue, but come on. There we go. So I have cut off a couple of millimeters of the PCB, and now we have the connector protruding, which is what I wanted. I think I'm gonna try to cut off a little bit of grind away a little bit here. Okay. I think I'm gonna declare this satisfactory. Now, let's double check that the board still works as it's supposed to. And it does. We're still getting 5 volts. That's awesome. So, that's the mod done. Ta-da! Yes. So now I'm just gonna hook it up to this, to the rest of this circuitry. And that's a handful of building blocks for the Bluetooth speaker. Same guy had another video where he switched an old PC's case to a DVD. It fit the interior so well you wouldn't know it was a PC box. But okay, I'm not following what you mean. Or like what kind of PC case and whatnot. But that's fine, no worries. Okay, let me quickly get rid of these probes. So they're kind of in the way. Also disconnect the battery. Come on. Oh, there we go. Liberated. He's not super professional, I just love how homemade he is. Yeah! I mean, I'm also into that. As you can see. Right. I wanted to touch up some of these solder joints, especially this one. Doesn't seem like there's quite enough solder there. So let me just squirt a little bit of flux there, add a little bit of solder, just to touch it up. Because the rest are nice, but this one seems a little bit anemic. Okay, that's looking better. Then this TP4056 charger board also has 2 pads to provide power directly, so not over the USB port. So I'm gonna quickly grab another pair of these connectors. You got a bunch of these 2-pole just to be able to keep my connections modular. I think it's nice to be able to do. Also, should probably clean up this. Get rid of this bit of clutter. Put the Dremel away. This grinding disc worked a treat. I'm actually surprised by how well it worked. So I only used a small bit of the disc. Let's just compare it to a fresh one. So not even, well, maybe a millimeter in diameter. So there's plenty of life left in that disc. Wait, and the screwdriver as well. And away you go. And then, okay. So I'm trying to follow a convention here that the male connector is the side supplying voltage and the female connector is the one receiving. So in the case of the battery pack is providing voltage in most cases. So on this board, this side will be receiving voltage. Let's get some flux here. Get it nicely reflowed. The hole in the PCB is quite large for some reason. Okay, still drowned in way too much solder, but that's fine. I did have a big blob. Let's get rid of the flux. Oh yeah, this charger board came with the USB connector not anchored in, so the solder, like through hole, solder joints were missing. So it was only attached by the SMD pins of the USB-C connector. Not very convincing. So let's solder it in, but turns out I'm not going to use it anyway. So we have that. Then, so this is ground, this is 5 volts. Let's get this connected. I'm not gonna thread those leads through the holes, because the holes are very small anyway. Just gonna use a solder blob and call it a day. And it looks like the soldering tip recovered in the end, so that's good. On its own. Again, let's wipe off some of the flux. Getting calendar reminders of some sort. I don't know if you could hear that. Sorry about it, if you did. I think you heard this one now. Okay. So got that cleaned up. Did I clean this up? I think I tried, but without too much success, but that's fine. Flux shouldn't really hurt anything. Okay. That's another cotton swab done. So let's run a full test. So first of all, we are getting 5 volts on the output of this. So that's a good sign. And then if I connect the trigger board to the TP4056 without the battery attached, it should be very confused because it cannot measure a meaningful voltage across the battery. But yes, so this LED the blue LED is on, and the red one is flashing faintly. which is kind of expected. Let's check the voltage that it's trying to push to the battery. $4.18. So that's expected. AI. Can I get this probe underneath? Oh. Having trouble making a solid connection here. Okay, we got a connection on the multimeter. So now if I connect the... Oh wait, no, that's the output voltage. That's the output to the downstream consumer. So this here is the battery. But that is also 4.18, which is expected. So there's no reason for that not to be the same voltage. So now if I hook up the battery, well, I might need to... Okay, I needed to reset the chip, but now it's in charging mode and it's drawing 200 milliamps from the USB port, and it's drawing it successfully from a smart charger, which is good. Now if I replace the smart charger with a regular dumb USB port, it should still have the same effect. And indeed, it's also drawing 210, 220 milliamps. The voltage is slightly lower because there are more losses on this cable. But yeah, it's all working as expected. So, mod successful. Beautiful. That is what I wanted to achieve today. And I'm quite happy with the result. So let's disconnect everything. And next step will be... So I have all the building blocks for a version 1. Let's move the multimeter out of the way. Also trim the spent solder wick. We don't need the soldering iron anymore. So we got the Bluetooth module, we got the drivers. Let me just quickly clean the nozzle of the flux bottle again. Before everything dries out too much. Yeah, we got the USB power trigger board with our little 5-volt mod working beautifully. That makes me happy. Then I will take the indicator LEDs from this charger board. I'll probably get rid of these two and solder on some extension cables and expose those in the box of the finished speaker. But yeah, so the next step will be to actually build a box and start to put things together. This holder for 18650 batteries has 4 mounting holes. Those take M2.5 screws. So I will just mount that to the inside. The Bluetooth board is going to be very straightforward because it has M3 mounting holes in the corners, so I can just screw it down. I will need to get some of these anchors in place. I got these nuts that you can either melt into plastic, or, well, in this case, what I'll try to do is it this size? No, it's a smaller one. What I will try to do is drill holes into the wooden panels that I'm gonna use, and get these nuts fixed in place with some UV resin. So we'll see how that goes. I will need to practice on a spare chunk of the wooden panel, get some practice with that before I cut the actual finished box. But I'll need to somehow improvise fixing these boards in place, since they don't have any mounting holes. So what we'll probably do is use something like 4, maybe 5 screws and try to like get them mounted around the edge. So here, 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 or maybe here, here, and one here. Then on this side and somewhere along this edge. So it's fixed in place. That's gonna take a bit of work. And same with this little circuit board. And this one from one side, it will be fixed in place by the panel that's gonna be sitting against it. But then maybe 3 screws, like one here, and one here. But yeah, that's gonna take some improvisation. But for now, that is it for DIY. So let's get some gaming done. It's 11 o'clock for me, so I can still squeeze in an hour or 2 of gaming. Let's play some Neo. By the way, I managed to knock a hole into this plastic box. So because I got the UV resin, so I tried to just patch it up with the resin, and it worked beautifully. I just taped the box, squirted some resin, shone a UV flashlight on it, and voila. Hole in the box patched up. So the resin works pretty well. Better than I expected. But enough of that. And then the next step, after I'm done with the first version of the Bluetooth speaker, next step is going to be to add a 5-volt boost circuit between the output of this, and the Bluetooth board. just to provide a stable 5-volt supply for this board, because like I said before, the Bluetooth microcontroller seems to be a little bit unstable when the voltage drops too low. And then another thing that I want to do is build a little charge level indicator circuit, and that's going to be fun. That's something I'm looking forward to, because I want to do that completely from scratch with some op amps, a bunch of LEDs, a voltage reference, and yeah, just measure and the voltage divider network. So I want to just measure the voltage across the battery and light up the matching number of LEDs. And I'll probably add a little timer circuit as well. So I can press a button to show the charge level. It will light up for a few seconds and then turn off, so it doesn't unnecessarily eat a bunch of power. So I have ideas. I'm looking forward to making them happen.